Welcome back to the MG Online YouTube channel. In today's quick video, we're going to be doing some machine work on this little MGB 18V cylinder head, which my customer told me is a 1972, making it over 50 years old. Now, I won't pretend to know the history of these British engines, but I do know that after cleaning up this head and inspecting it, it's ready to have a complete valve job done in order to get it ready to get back on the road. My customer supplied me with some new valves and a set of manganese bronze valve guides to be installed. So to begin with, we have the head fixtured in the TCM 25 valve seat machine, and we're going to level up the head in order to cut down the top side of the old valve guides. The software I normally use to pull specs is pretty light on the specs for these engines. So in this case, we'll simply measure and take note of the intake and exhaust guide heights so that when we install the new valve guides, they're installed to the proper height from the spring pad. Once the guides have been cut flush with the head, we can come back with the correct size driver, and using the air hammer, we can drive all of the old valve guides out of the head. Before going ahead and installing our new valve guides, we first use a wire brush to clean out the guide bores and ensure that they're free of any burrs or debris that would cause an issue when installing the new guides. With the bores and guides lubed with a bit of press fit lubricant, we'll go ahead and use a rubber hammer to start all of the new guides straight, being sure to install the exhaust and intake guides in the correct position as they are different lengths. With spacers set to the guide height dimension we noted earlier, we can use an air hammer to finish driving the guides into place until our driver bottoms out against the spacers, ensuring that all of the intake and exhaust guides are installed evenly and on spec. As you can see, at this point the head looks very similar to the way it looked when we began, but now with our new bronze guides installed as opposed to the old cast iron guides. We're not done with guide work yet though, as we now need to measure the valve stems of our new valves and hone the guides for the proper valve stem clearance. Starting with setting our bore gauge to the dimension of our intake valve stems, we see that as installed, the new intake guides aren't very straight, measuring anywhere from about 0.5 clearance to over 1.5 thou clearance. In a perfect world, the guides would end up being perfectly straight, but sometimes you have to work within the parameters that you're given. So we're going to be doing our best to straighten out the intake guides with the hope of hitting 1.5 clearance. Using the diamond guide hone, opening up the diameter just a tad was pretty quick, and after cleaning the guide, the pilot that we will use when doing our valve seat work felt like a great fit with no extra clearance, as you can see here. It's typical for the exhaust guides to require a tad more clearance than the intake due to the additional heat that they experience, and most times you can size the guides to the same diameter because the additional clearance is built into the stem of the valve. However, in this case, the exhaust stems were actually slightly larger than the intake stems, so we're going to be forced to open up the exhaust guides to a slightly larger diameter in order to hit the 2,000th stem clearance that we're aiming for. As such, this required a little bit more time with the diamond hone, but not too much. Before moving over to the SERDI for our valve seat work, we removed the manifold studs and discovered that somewhere along the way someone had incorrectly retapped the end stud from fine threads to coarse threads, which is likely the cause of the increased wear around that exhaust port as the stud was loose due to the poor quality of the threads. To avoid any future leaks, we went ahead and drilled out the old threads and installed a helicoil to bring the hole back to the correct size of 5/16 inch fine threads. For a quick recap, the SERDI valve seat machine uses various air floats in order to locate the valve guide pilot perfectly concentric to the valve guide, as well as to align the cutting tool to the exact angle of the valve guide before the floats are locked in place and the tooling becomes rigid for machining. Due to all of the valve seats having substantial wear, we determined that both the intake and exhaust valve seats should be installed. With the intake caterbore cutter in the machine, we touch the cutter to the casing before zeroing the spindle depth readout and setting the spindle lock to the thickness of the valve seat we have chosen, which are 7/32 inch depth in this case. The intake seats chosen are 1 11/16 inch OD, and we have our spindle running at around 250 RPM, slowly feeding the cutter into the head with a bit of intermittent coolant until we hit that spindle stop. Cutting into the water jacket is always a concern when installing valve seat inserts, so once the counterbores have been cut, it's important to closely inspect the head, and oftentimes I even take my knife and push into the corners to ensure that we haven't hit water or come very close and junked the head. Knowing that we're safe to move forward, I've moved the head down off the SERDI in order to drive our valve seat inserts into the head. Once again, our driver uses a pilot to align to the valve guide, and after a few solid hits with the hammer, the seats bottom out in the counterbores. With all of the intake valve seat inserts installed, we repeat the process for the exhaust seat inserts with a 1 3/8 inch diameter counterbore cutter. If you've made it this far through the video, we want to say a huge thank you and remind you to hit that like button, subscribe, and drop a comment, as my dad and I love reading what everyone has to say. Also, be sure to visit our website at the link in the description. With the intake and exhaust seat inserts fully installed in the head, we now have quite a bit more material to work with to form our seats. Starting with the exhaust, we're going to set our tool to the correct position to center our 70 thousandths inch wide seat on the exhaust valve, and then transfer that measurement to our seat cutter and adjust the cutter out to that dimension. After cutting one seat and checking our work, we see that we can adjust the cutter out ever so slightly to get the seat contacting the valve face closer to the center. Also, due to the port design of this head, we need to open up the inside of the valve seat quite a bit to get a better blend from the seat to the port. Ideally, we would be able to run more of a bottom angle before going straight down into the port, but the way these heads were designed, they really only have a 45-degree seat itself with almost no top or bottom angle. Before finishing the rest of the exhaust seats, I took a cartridge roll and did a tiny bit of hand blending of the bottom of the seat into the port, and finally it was time to put our 45-degree seat angle on for the exhaust side. Again, when finished here, we see hardly any bottom angle, a 70 thousandths inch wide seat angle, and almost no top angle into the chamber. On the intake side, we're going to follow a very similar process, starting with setting up our cutter to the proper diameter using the tool to transfer the measurement from our intake valve. In this case, we're putting a 40 thousandth wide seat with a 45-degree angle. Once again, before cutting our seats, we went ahead and opened the inside diameter of the seat inserts in order to blend well into the port. Running over 600 RPM on the spindle, the intake side looks similar to the exhaust with nearly no bottom angle, the 40 thousandths inch wide seat angle, and nearly no top angle as the seat transitions into the combustion chamber. With the valve seats cut, the head is really starting to look a lot like it probably should have looked over 50 years ago when it first left the factory. For fun, I did a little valve bounce here on the exhaust valve. I don't know how accurate of a test this really is, but people say that it's a rough way to represent excellent concentricity, as a valve won't bounce on a seat that isn't concentric to the valve guide. That being said, our preferred method of checking our work here in the shop is by checking each valve and seat with the vacuum gauge on the machine, as it's a better simulation to check whether or not a valve will seal. The valves are brand new, but I went ahead and ground them quick on our machine to be sure that they were up to par to match our freshly machined valve seats. As another verification of quality, we also like to double check the depth of our valve seats relative to the surface of the head, and we like to see no more than 10 thousandth variation in this measurement across all of the exhaust valves, and no more than 10 thousandths variation in this measurement across all of the intake valves. Moving on to resurfacing the head, after our first light cut, we did see some pretty funny variation in the surface, but not to worry, as with another couple of cuts bringing the total material removed to 3.5 thousandths, the surface was clean and flat. As noted earlier in the video, the manifold surface was in pretty rough shape, especially near the damaged threads from that stud, so I set up the fly cutter to resurface the manifold surface and get it in better shape as well. It ended up taking several passes, and at the end I actually switched to a different cutter as I wasn't happy with the surface finish that the first cutter was leaving. And with that, this little MG head is looking great, and it's ready for a final wash before heading home with the customer for final assembly to hopefully live on another 50 years. Thanks for watching, and we'll see you guys in the next one.